Hey everybody, or somebody, or nobody. Hey nobody, hey nobody watching me. You'd be surprised how good I am at talking when there's absolutely no one listening. My name is Eric. I'm making a game. It's called the Godkiller. It is a 3D top-down puzzle-solving adventure game. And I begin every stream with a demo. This stream is not an exception. I just said every stream. Doesn't that imply that this stream would not be an exception? Every stream, every single stream begins with a demo, perhaps with a little preamble like this one, but really I get right to the demo. I get right to it. I don't mess around. I don't keep on talking like an idiot while everyone's attention runs out and they stop the stream and go someplace else. No, I would never do that. I would never do that because it's so important to me to demo my game, which is what I'm going to do right now. Right now, I'm going to demo my game. It's been a long day job day. It's been a long work day. I spent a fair amount of time at my day job today doing work, and now I'm settling down to the fun work of my game, which is cool. But let's do a demo. And actually my demo is accomplished not by hitting the play button, but by staying in the editor. So what did I do yesterday? In the editor you see these kind of ugly little lines all over the roads. They're a diagnostic. They tell me which way a creature who's on the road is going to move to reach a given target. Let me explain how the road works. Okay, imagine you were on a real road in the world, and you saw one of these signs that has arrows pointing to every possible place you might want to go. I think we've all seen these kind of signs. Let me see if I can find one real quick. Crazy street sign. Nah, these will be silly ones. You know the ones where it's got one arrow pointing one direction for one town, a different arrow pointing a different direction for another town or destination. These are all going to be like everyone's bullshit, photoshopped signs. Direction sign. Like one of these. Or this one. Here we go. See, this is perfect. Okay, so you're walking down the road, and imagine that no matter where you wanted to go, no matter where in the world you wanted to go, you could look off to your right, just to the side of the road, and there'd be a sign, and you'd think, no, it won't have the destination that I need on it. But you look at it, you read through it all, and actually it does. It's got it. Every single place that you want to go is on that sign. It doesn't tell you how to get there. It doesn't tell you the full path to get to your destination. It only says go that direction. Now, if you looked at this sign and it said, it said Chicago, move in the direction the arrow's pointing. Well, you start walking in that direction, and maybe after a bit there's another sign just like this one, and it's got a different direction, like because you got to go around a mountain or something like that. Anyways, just imagine, back to my game here, that every one of these squares has inside of it the equivalent of that sign I'm talking about. It's got directions to every possible place that you might want to go. Not full directions, just the next step that you should take. So on this road, this magical road, right now, they all say go west. Let's see if I get it facing the right way. And this diagnostic here is telling me on this square for a given destination. And by the way, over on the right, here's where I set the destination. And I'm attaching a target in the inspector, it says the game object called the player object. That one's got the coordinates that we want to get to. Okay, so this square says that for this one destination, the step you should take is west. So you could follow that, and you could go to the next step over, and it would say go west again. And then you'd be off the road. And then, actually, those are bad directions. The player is nowhere in sight. So I did not create all the pathfinding that would put good instructions at each square. What I did do was I created everything but that. So there is some analysis performed on the level during a period of time I call pre-processing, and it simply writes some bullshit nonsense information for instructions to a file. A serialized set of data structures goes into that file, and then when you load the level, it loads in that file. That data structure, I call it the roadmap, and then it applies all those instructions to each road square. Okay, so all that works, and there's this diagnostic thing I've got in the editor so I can check out the path mapping, but there is no real path mapping yet. And that's what I want to do in this session. I want to come up with actual instructions to get to every possible place you might want to go on these squares, or at least make a start at it. I don't have a lot of time today, and that is a giant task that I just described. But by the end of the session, I want to see some kind of slightly useful, maybe bug-ridden advice on these roads about where creatures ought to go to reach their destinations. I just want to see something there. I expect that by the end of the session, there'll still be bugs. There'll still be things that need to be refined. I don't think I'll get the vertical movement, which would direct you to go to steps. But I think I'll get something, and it will look like pathfinding. It won't be perfect. The other thing I didn't quite explain is how the roads work with pathfinding for the whole game, and I think I can show that with a quick demo. So basically, creatures are stupid as far as what path to take until they happen upon a road, until they step onto a road. After they step onto the road, suddenly they have a lot of advice from the road about where to go, and they'll follow until they get kind of close on the road to their true destination. Then they'll step off the road, and they'll continue on with their kind of stupid behavior to get close to the player. So this guy over here, he's trying to get to me. I'm going to lead him so that he ends up going onto the road. He's doing something with the ice there that's maybe not real intuitive to someone who's not familiar with the game. Okay, but now he's following me. So I explained that his behavior is kind of stupid until he gets on the road. And since the road is actually right now not very intelligent, his behavior will get stupider when he gets on the road. So I'll lead him north. Now he's going to start heading west. And he's actually going away from me. He's not going towards me at all. And that's because what I was showing you in the diagnostics, every single road square was pointing west, even though that doesn't help this creature get to me, the target. At least most of the time it would not. So that's kind of how it works. Now, as soon as I take him off the road, he'll stop listening to the road for where he should go. And then he just beelines for me. Bring him down to the road, and he's heading west again. And now he's just kind of dancing on and off the road. When he goes off the road, it tells him to go towards me. Then he gets on the road, tells him to go back west. So it's hard to see it because it's all dark. Anyways, so that's the demo. Now I'm going to see if I can get some pathfinding in. I think I'm going to spend maybe a couple hours on it. I just had a little bit of a late start today. Lots of work at the day job. Went a little bit long. Alright. So I gotta admit, at the start of this, my ideas on how to do this aren't very well fleshed out. It's a little bit like having not a blank page, but more like a book that was written previously that's missing the most important chapter. It's got everything else in it. It's got, maybe the setup and the background, and then it's got the ending, but some piece in the middle is not there. The most important chapter is not there yet, and I gotta think it up today. So here's the nonsense code I wrote, where I just said we're just gonna say that every step will be west. It's right here. So let me start thinking of my algorithm. Do a little pocket design. Something's wrong though. I don't have a root beer. I gotta go down and get my root beer. I'll be right back. It won't take me long. I promise. Okay, I drank all the root beer. I drank it all when I went down. I guzzled it right out of the 2 liter, and now it's all gone. I had a moment of sadness when I realized that I couldn't bring it back up with me because I already drank it. That's alright though. I still got my root beer. Alright. What are my requirements for this? Generate instructions to reach any square on same layer for each road square. So layer is just the XZ axis. Okay. Optimal paths. I don't want some correct but strange and unintuitive path to reach someplace. And that's it. One requirement that I don't have is for it to be fast. This algorithm can be super slow, and it's cool because it's all done during pre-processing. A little chat separator there, so that I can see if somebody new chats instead of just looking at the old. Okay. I don't have a lot of requirements. I think this maybe a simple requirements, difficult solution, perhaps. I don't know. Breadth first. Let's see. Oh yeah, I'll add one case. Successfully handle, I'll call it the donut case. Two paths can arrive at same point. Pick the optimal one. I guess that's a restatement or a clarification of optimal paths. Easy. Pretty sure there's going to be a breadth first algorithm. I'm not going to do a greedy search. There's no point because I'm getting into flood filling or searching through the entire set of nodes or squares in the layer. I'm not trying to intuitively find the quickest way there and maybe reach there ahead of searching for everything. I'm just going to start with the idea that I expand out to every single square. So breadth first, but it's like a fill to every single square. Let me see. Let's say I've got, I'll just put in like a little test. I'm calling the pound signs obstacles, and we'll say that the road square is here, and I'll have a data structure which more or less has the same dimensions as this other thing I'm looking at representing my game world. So I'll fill this in, just kind of following my own algorithm. So we can say it's like a flood fill. It's a breadth first expansion out to all the nodes. So starting from R, I would say we're going to process north, let's do north, east, west, okay, and each one of these searches is going to have associated with it the initial step you would take to reach that particular destination square. So each one of the 4 directions will have a certain number of squares that you would get to that all begin with the same step. So if I expand out from the second node I created, or search node I created, all the neighbors will also inherit the initial first step. So it'll be north, north, north. And as it's a breadth first search, actually I did it maybe out of order, because I think I could just use like a FIFO queue here. I'm trying to be a little bit algorithmic in how I fill this in, simulate how a computer would do it. So alright, so then I think it would go, this guy would be next, east, this guy next, west. And then I come back up to this guy, and I see that all of the neighboring squares are already processed. So this guy would already be processed, so he would just kind of peter out. Okay, so now we go east. That one will go there. This guy here, west. Okay, then I come back up to north. And alright, yeah, I mean, I think, yeah, this is probably gonna work. I think this is true, but I don't know that it's true. I think it's true that a breadth first search would, by virtue of being breadth first, would find optimal paths. So if you're expanding the perimeter of your search over all possible squares, but you expand each point in a like an even distribution, like you don't focus on one node and keep filling it out, like east, 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 and then like after it's all exhausted the possibilities, then you switch over to one of the other nodes, west or north. If you're just sort of evenly expanding out your perimeter, my assertion is that it gives you optimal paths. Like maybe occasionally there might be some small hiccup where one path is slightly less optimal, maybe. That part I'm not sure about, but I do feel pretty confident that it shouldn't give a grossly suboptimal path. Like maybe at most a path might be suboptimal by 1 square or something like that. Okay, so this search has to basically fill out all squares it can reach, and once that is done, I can compress it with my run length encoding. Alright, so algorithm is create byte array to hold all instructions. Instructions array. Processed list to track all processed squares to be processed. FIFO Q track all squares to be processed. I mostly wrote this already, like the A-star thing. All right. Let's start refactoring some of this. Okay, other data structures I need. List. I think I probably will have to do that eval thing again, the eval square thing. Oh, I don't need all that though. No, this is much more convoluted than what I need. Okay. Okay, let's see. So I think C# FIFO Q. I think it's going to be a deck. Or maybe it's Q. Let's see. Yeah, that's it. So let's say Q eval square. And the other one is list CRH processed. Okay. So then we add the first square. It's going to be real similar to the other one I wrote. Let's just go ahead and copy and paste, and then just whatever needs to change, I'll change it. A lot will need to change, but it's a little bit faster than going back and forth 5 million times. keep using this. I keep copying it. That's a sign that I should refactor it. Yeah, that's what I'll do. It's under direction. Let's just make one called flat orthogonals, and that'll cover it. Are you monster or a monster for using the light theme? I think it's like a age thing, to be honest. It's like your eyes get more tired as you get older. So, I don't know. To me, it kind of makes sense to use more light, have more light coming at you. Now, are you talking about using a light theme in your work, or are you talking about using a light theme in your website, your web app that other people are going to use? So like in your IDE, like you could have a dark theme in your IDE. Yeah, it's not that big a deal. It's just like there's nothing like, I don't know any bad side to it health-wise or anything like that, but it's just easier on my old eyes and like people over the age of 35 maybe to go dark. You gotta look at code all day, you know. Yeah. But most things I have set to dark. Visual tools have a different reason for being dark. And so like something like Photoshop, the thing that you're working on, you want it to have all the colors presented as clearly to you as possible without being misinterpreted because of other things in the chrome surrounding it that would cause your eye to misinterpret. So Photoshop and the Adobe Suite in general has been real nice about keeping everything dark for the last 10 years or so. I think they made the switch to default to that a while back. But then like for code stuff, I don't know, it's not that bad. It's just an eye strain thing for me. Let's see. Oh, God. Oh, man. That gives me such a weird feeling to see. I've had the same thought before. It just seems like all the really super cool designers got sucked up by Apple or something. or they've got more say. You know, Apple is always like such a design-driven company. Let's go back to dark. Yeah, that white light color, that was just nightmarish for me. Picturing a whole day doing that. It just sounds terrible. All right. I got this. Oops, not that. Okay, what does it need? It needs... Weird. I wish it would explain the rationale for the warning. Let me see. Why is that something I should care about? Oh, nice. Just JetBrains is doing a good job of documenting their linting. Okay, I think I did this wrong. That's the wrong method. Is there an NQ? Yeah, that's the one I want. There we go. Yeah. the linting that I get in Writer is really good. It has actually saved me from quite a few bugs. Okay. Also, I'm just going to make a note. To delete. What about the whole module? Okay, just so I don't forget about that. Okay, let's call this that's actually a better name. It occurs to me that the process queue may be redundant with target steps. So I don't know that I need processed. Yeah, let me even do one more of these to just indicate there's nothing there. Let's yeah, I don't think I need this. Um, okay. let's do it this way. Wow, what if this is it? Might be. It seems like it's all there. Alright. Let's give this a shot. There is a chance that I'll infinite loop. I really don't want to. Infinite looping means force quit, and I just don't want to have to worry about it. Okay, int iterate count. So see, I'm going to teach you a technique here. Serious, this is good right here. I'm passing on the wisdom. If you've got a complicated loop and you're not 100% sure that it's going to exit, put like a little safeguard here. So say there, that way I'm guaranteed no infinite loop. Save this. Okay, that makes sense. Oh, we gotta check for if it's processed or not. On the other side, let's just yank that out, simplify the code. Don't know why I'm not getting a breakpoint. It's nonsense. Let's go back to here, generate the roadmap. There we go. Alright, there's my uncompressed. Yep. So this should be not 0. What's 56, 63, okay. Yep, okay, cool. I'll check north. South. West. Okay. So now it should go to the north square. To be processed should have 4. Yep. And the first one that it should pop off should be this one going north. Yep. This is pretty wasteful though to add all these onto the queue. Maybe I do want to have the process check. I don't know. I don't necessarily have to. I'll see how long it takes for it to finish. Doesn't seem to be taking a lot of time. Okay, 7 to be processed now. So this next one should be south. Then we got west. Then we got east. Then we got some northeast. North, 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 north. Looks healthy. Alright. I feel like this is proceeding as expected. I don't need to iterate through all those thousands of squares. Let's just see what the end result is. Nice. 878 bytes for my target steps. So if I see a whole bunch of these 255s, that might indicate to me that I should expand my run length encoding so that it allows for a run length that's larger than 255. And I can do that pretty easily. I don't want to optimize yet though. I do see a lot of 255s in here. Yeah, that would slow down my decoding if I added like escaping to provide like a larger run length encoding. So yeah, I'm not going to do that yet, but 878 bytes, that's not bad. That's not bad. Let me think what the savings would have been for that. 109 times 103. So it is 878 divided by 1. Okay. 8% savings. I would have... Wait a minute. No. Hold on again. 109 by 103. Yeah, that's 11K versus 878 bytes. So actually I got to like 7 or 8% of what it was. That's real good compression, actually. I mean, I could get it more compressed than that, but this is cheap compression. Cheap and effective. Run length encoding is like one of the cheapest types of compression. It's very simple. Alright. So let's just hit play. Seems to be going pretty fast. I might have to take that back. What? Oh, still got some of those, okay. It's going to be 0. I do kind of wonder where... So that's not really good. So it's looking at the target CRH where the player's at, and it's finding 0. There should have been some way to reach the player. I need to get to a point where I can see the visualization of it. So let me just stop the debugger. I mean, that is a good that is a good assertion to have. It is meaningful. It is actionable, but I just want to get to, I just need to be able to see what's going on. So let's turn it off for now. Okay, so completed. Does take a quite noticeable amount of time for it to complete. All of these are saying direction none. Every single one. I wonder if the player is reachable. Should be. She's on the same layer here. Oh, the ice makes it tricky. Perhaps. Perhaps. Okay, let's move the player outside. Let's get her past the ice. Okay, the player cam. Okay, as soon as I moved her outside, the road instructions updated. I can't remember. Is the... Okay, the ball is showing the endpoint, so that's saying go north, go north, go north. All of these are saying go north, but some of them should be saying, like around here, go south. They're all saying go north. So something's off. I do like seeing all of the roads update quickly. They're just not updating to intelligent instructions. So something's screwed up. Alright, let me just do one and not output. Let me output the uncompressed instructions for one road square and see what that looks like. Because it feels like I can't see it yet. I can't see what's going on. Let's do it before the encoding. Okay, that's gonna be so many. Okay. Just want to see one. It's gonna be such a torrent. So let's go here. Let's generate the roadmap. Okay. I get this in a fixed width font so I can see it better. Alright, how to read this. I don't know which square this was for. Oh, it probably was this one. Yeah, actually it would have been this one. So it's saying if you want to get anywhere over here, you go west. That's pretty good. I definitely know how I can optimize this better. Like anytime I see a 0, that's a square that can't be reached, but I could fill them in with ends or whatever the previous value was. I could just fill them in. I could say let's go n. It won't matter. wow. Yeah, it just occurs to me that most of the time there'll just be large blocks of all the same instruction to get to squares here or here or here or here. It's like if you want to go here or here or here or here, all of them you begin with one step to the north. If I fill in the zeros, then it's just going to be a giant block of ends. Down here, a bunch of W's. If that's really the norm, I could just reserve 2 bytes for the run length encoding, and then that will give me what's 2 bytes? Up to 65K. I think that's right. Hold on. Now I'm doubting myself. No. 16-bit. 65536 or something like that. Something very close to that. So 2 bytes. That would start if I fill in the zeros and I store in 2 bytes. It's mostly just going to be like this would get down to like 20 bytes or something like that. Something just crazy small. There would only be 4 run lengths to encode. It would be 12 bytes for this one. I don't want to look at the other ones. Oh, there's one thing that's bugging me though. It doesn't seem like it found all the obstacles. Doesn't seem like it at all. Like this looks like an obstacle. And that looks like an obstacle. I would have expected to find obstacles around the exterior. Yeah, this is weird. I'm not gonna optimize the run length encoding yet, because I see some other problems here, and optimizing the run length encoding might hide them. So if I get rid of these zeros, then I can't really see where all the obstacles are. Yeah, it's also a kind of guard for the player trying to reach a spot you shouldn't be able to reach. Because I have that assertion that I disabled, which says, you know, the square that you tried to reach, it doesn't map to a place that you should be able to reach. But there's something off in this. It's pretty fundamental. Yeah, this map doesn't look right. Let me look at another one. In fact, let me set this so it doesn't calculate every single one. This one will just calculate the first one. Oh, I forgot. Some of the road squares are not on the bottom floor. That could be why. Okay, this one is on the same height as the player, which is good. It's a useful one for me to look at. Be easier for me to see what's going on. This one looks better. And the other one probably wasn't wrong. It was just higher up and it didn't have the same obstacles I was expecting to find. Yeah, now this is looking more like the space I'm used to. Here's like the two buildings you can walk underneath. There's that little alcove you can get to. And again, I'm really looking forward to optimizing this run length encoding for the zeros, because it'll just be so cheap to store that. And cheaper to look up too. If you've got less segments in the RLE, you can process them faster. So looking forward to that. Is there some limit on the number of what's going on? I thought I had everything. Maybe it doesn't want to let me paste everything. That could be it. Huh. That's weird. Okay. Oh yeah. So where is the... There it is. Yes, this is a good one. Yeah, this is just a few steps east of those stairways that go up, the road stairs. And if the player was here, it would correctly be saying go east to get to the player. If the player was here, it would say go south. And then like you'd be on a different road at that point, and the next road would have an entirely different set of instructions there for getting the player. But it's just saying the first step to reach the player over here is south. It's nice to see a bunch of ends come down here. It's looking pretty optimal. Okay. Around here, this is where the breadth first search pays off. is when you have an obstacle that you could go around one of two ways. Well, the node searching would have expanded the perimeter in an even way, and it would have explored here, and then over here it would be down to here. It would keep exploring, and south would win. South would get out over here faster. Actually, no, I'm saying it the wrong way. North would come around further this way than south did. I'm being extremely inarticulate, but that's okay. No, okay, here's another way of looking at it. If I'm here, I go 1, 2, 3, 4. I'm going to travel all the way over here and count my steps. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nah, that's too much counting. I can just eyeball it. You just eyeball it. You can see it's about the same distance from there to there. It's about the same distance. Yeah, this all looks pretty right. Definitely looks right. So there is some kind of problem still. Not sure what it is yet. My session goal is just to see some kind of useful pathfinding happen. It can have bugs in it, but I don't want it to be like as broken as it is right now. It doesn't give me any kind of usefulness. So I gotta keep working. There's gonna be a small bug here, not a giant bug. I think the approach is right. There's some bug. The algorithm is right. My brain's getting a little bit tired, so I'm starting to feel panicky. I gotta figure this out before I get too tired. Alright. So, what is the problem? What is the problem? Road instructions. Generating correctly. But road square diagnostics showing all the same direction. So, things that could be wrong. I think that's it. I suppose serialization. So the thing I could do is write a couple of functions to encode and decode. When I encode, okay, number one, now write my approaches out for debugging this. Right, ROE encode and decode functions. After encoding, call decode and check that result matches original. Okay, that's one thing I could do. Check data structures after load. It's gonna be a lot easier if I've got this kind of thing though, encode decode. Yeah, let me start with this. Encode. And let's make a symmetrical decode. I was thinking, why don't I just yeah, just store the rows too. Be a lot simpler. By the time I'm done with this, it'll be a really small structure anyhow. Oh, but I don't know it until... okay. Hold on. Get rid of that. Okay, so decode, and then let's assume we need calls and rows in that call. Alright, so I've got the index. If I divide it by the number of columns in one row, I'll get my row. If I modulo it by the columns, I'll get my column number. What? CRI columns out 2 ints. What? What do you want? What? Oh, that's not right then. This has 4. 1, 2, 3, 4. This has, oh, there we go. Getting tired. Let's see if this works. Now put that back. Why does it have to be 7:58? Oh, Mr. Meeseeks is starting to get a little sketchy. Nope. Okay. Well, that's good. That is good. What does it equal? 0. Why would it equal 0? Alright. Oh, I forgot to increment it. Okay. Wait, no assertion? Now I don't know what happened. What happened? Okay, that's an exception. I'll just play. Okay. What? Either a problem in my encoding or my decoding. Well, let me step through the decode and see if where it stops making sense. This should be 0, 0. Right call 0, right row 0. This one should be 1, 0. Yep. That's a lot to go through, so let's come up to here. Okay. So now my CRI, where are you at? 255. That's cool. And calls is going to be, okay, 109. So when I come down to here, it should be like right row equals 2, I think. Instruction 0, more 0. I don't see anything obviously wrong in the decoder. In fact, I trust less the encoder than the decoder. I think I'm going to kill 2 birds with 1 stone. Because I already know that I want to have run length equals 2 bytes. So if that's the case, then I can simplify this by, like, there's probably some logic error inside of here. It's a little complicated. Some off by one type thing. I might as well write it how I intend to. I might create a different bug when I write it as I intend to. I might fix the bug that is already present though. If I'm going to create a new bug with this change, I'd rather fix the bug in the new code than fix the old code, then change it, then fix a new bug. So although I do think I spotted the bug already. Alright, back up. Yeah, I do think I got the bug right here. I'm going to try it with this smaller change first. So if there is a new step direction, I have to reset the repeat count. That's the first thing. Okay. Let's see what happens. Alright, still got some kind of oh, this is cool. I've still got my call stack here. Okay, CRI is at 10831. It might be a one-off error here on the assertion, not the actual code. So let me check. 109 times 103. Nope, that's quite a bit different. Quite a bit different. So I think there's still an error in the encoding. Although I did fix one of the problems in it. But let's go ahead and move on to the 2-byte repeat count. So it'll be byte repeat count divided by 256, byte repeat count modulo by 256. So say the value was 256, and the first byte would store 1, and the second byte would store 0. If it was 255, the first byte would store 0. 255 divided by 256. And the second one would store 255. If the value was 257, first byte would store 1, 257 divided by 256. Second byte would store 1. Let me see. I've got, if I have an off by 1 when I continue on. I do. Yeah, so that should be 1. And this can be 1 too, but no, I can't, because the first one's got to compare itself to itself. Okay. But on this one, after I add the step, I'm already looking at the next one. I'm saying I've got 1. Repeat count 1 here. Let's think about exiting out. I think this is right, but I have to add. Let's encapsulate this. Say add short. Oh, short is already a... Yeah. Well, I think short is maybe ambiguous, so let's say, yeah, okay. Or I should be briefer. Ah. What? Well, I mean, if I'm going this far, let's keep going. Nah, let it be. Let it be. That there. Give me 16-bit RLE. I think I corrected off by one error here. Now let's fix the decode. Okay, then there's this guy up here. Okay, let's try it again. Oh, 8:21, it's gotten so late. Mr. Meeseeks wants to die. So it's going to repeat for a while there. Repeat count 660. I like it. Big number. Let's take a look at the bytes. 660. That's 2 times 256 is 512. Plus 148 is 660. Good. Okay, what's your repeat count? 97. Well, let's take a look at the bytes. Okay, looks good. And the current step, it should be something besides 0. It is, good. Okay. What is the repeat count? 2077. Oh, I'm curious. Okay. So that is a little bit larger than before, but still in that nice 10%-ish range. And when I take out the zeros, it's going to get real small. Can't wait to do that, but one thing at a time. Okay, then let's go in, see if we can decode it successfully. First, I'll just go ahead, leap of faith. That means that this assertion passed. That means when it got to the end, it was matching. Okay. So I expect this is going to be in good shape, but let's take a look. Bunch of zeros, and it went to 660, which was, I mean, that'd be quite a ways down. 660, and okay, and then it went, yeah, okay, it's looking healthy. So let's just go up, and let's see. Here's the moment of truth. Yes, okay, awesome. So now I verified my encode decode. Pretty confident in it now. I saw problems in it before. I fixed those problems. But there is still this other function that searches through until it finds the step it needs. I'll go ahead and see if I can breakpoint that one too. Here we go. If you want to know how to get to 58, 67, 12. Now the road square that it's using may not have any target steps though. No, it does. What? Huh. Yeah, I kind of don't know how that's possible. Yeah, these are garbage. These are garbage. Okay, so I need to... This will fail. It will not do good things. Let's get rid of this. And come back here. Yes. Yes. Oh, the dopamine is flowing. It's saying go north, go north, go north. Over here it's saying go south, go south, go south. Right here it's going west, 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 west. Now I gotta hit play. I gotta see. I gotta watch the guy follow around the road. If I can be that lucky. Oh, I do need to figure out some way where it's not generating the roadmap every single time I hit play. Because that is a lengthy calc. See, he's following the road. He's following the road. He's staying on the road. I love it. Okay, the road said, get off the road. All right. So it's not the level isn't set up very well as far as forcing the need of pathfinding. So it doesn't make a great demo. I may contrive tomorrow. I may contrive some situations that force pathfinding. But I have accomplished my session goal. I do have some kind of real pathfinding working. And the power of it, like, I know what's possible. It's not being displayed yet. The power of it is that I could have 100 of these guys running around. Probably more, probably 500, some ridiculous number. They could all have different paths that they want to get to as well. It's all pre-calced. They would figure it out real fast. Like, I would run out of CPU for other things besides pathfinding before. I would be CPU bound on the pathfinding, because that lookup is just super fast. And as soon as I add in like the removal of zeros so that the run length encoding is simpler, and that means they're going to search through that data structure even quicker. Like, there might on average be only like 10 elements inside of a run length array. So that's victory, and I'm going to stop right there. It was a long session, but it was rewarding. I figured out some hard things, and I got a good result. All right, for whoever is lurking, thanks for joining me. For whoever left and went off to other things, I forgive you. That's fine. See, you're great. Stopping the stream. Stopping the stream. Stopping it.